Tonight, we're going to shrink the universe. Not literally, of course, but in a way that might actually let you understand it. Because here's the problem with space. The numbers are so large they become meaningless. When I tell you a star is 10 trillion miles away, your brain just shuts down. It's too big. You can't visualize it. You can't feel it. It's just noise. But what if we could shrink everything down? What if we made Earth the size of a grain of sand, something you can hold between your fingers? Something real and tangible, and then scaled everything else accordingly? What would the universe look like then? How far away would the moon be? The sun? The nearest star? By the end of this journey, you're going to understand cosmic distances in a way you never have before. Not through abstract numbers, but through real, physical scales you can actually imagine. And I promise you, what you're about to discover will change how you see everything. Asterisk before we begin. If you find this kind of cosmic exploration fascinating, a quick like or subscribe really helps the channel grow. It's a small gesture for you, but it makes a huge difference for me. Now, let's shrink the universe and see what happens. Asterisk hash has the grain of sand asterisk first. Let's establish our scale. We need to pick a grain of sand and decide exactly how big it is. Asterisk a typical grain of sand is about 1 millimeter across. That's small enough to hold between your fingers, small enough to barely feel, but large enough to see clearly. If you go to a beach and pick up a handful of sand, most of those grains will be somewhere between 0.5 and 2 millimeters. We'll use 1 millimeter as our standard. Asterisk Earth has a diameter of about 12,740 kilometers. That's roughly 7,918 miles. For our purposes, let's round that to 12,700 kilometers or 12,700,000 meters or 12,700. 0 millimeters, asterisk. So if we shrink Earth down from 12,700,000,000 millimeters to 1 millimeter, we're shrinking it by a factor of 12,700,000,000 to 1. That's our scale ratio. Everything else in the universe needs to shrink by exactly the same factor. Asterisk, this is important to understand. When we shrink things proportionally, distances shrink by the same ratio as sizes. If Earth becomes 12.7 billion times smaller, then the distance to the moon also becomes 12.7 billion times smaller. The distance to the sun becomes 12.7 billion times smaller. Everything scales together. Asterisk now, with Earth the size of a grain of sand 1 millimeter across, something you could barely feel between your thumb and forefinger. Let's see what the universe looks like. Asterisk hash hash. The moon. 3 feet away. Asterisk the moon orbits Earth at an average distance of about 384,400 kilometers. That's roughly 238,855 miles. Asterisk. Using our scale ratio dividing by 12,700,000,000, the moon in our model would be about 30 meters away from Earth. That's roughly 98 feet, or about 33 yards. Asterisk, let me put that in perspective. If Earth is a grain of sand in your hand, the moon would be another grain of sand, actually a slightly smaller grain, about 0.7 millimeters across, sitting about 100 feet away. That's roughly the length of 3 school buses parked end to end, or about 1/3 the length of a football field. Asterisk stand at one end of a basketball court. That's about 94 feet long. The moon would be just beyond the other end. Asterisk, think about that for a moment. Earth and moon, in this model, are 2 tiny grains of sand separated by the length of 3 buses. And in between, nothing. Just empty space. No air. No atmosphere. Nothing. Just vacuum. Asterisk, this is one of the first things that becomes clear when you scale the universe down. Space is mostly empty. Even between Earth and our closest celestial neighbor, there's an enormous gap relative to the sizes of the objects themselves. Asterisk, the moon is also smaller than Earth. Its diameter is about 3,474 kilometers, roughly 27% of Earth's diameter. In our scale model, the moon would be about 0.7 millimeters across. Still visible, still a grain of sand, but noticeably smaller than Earth. Asterisk, when Apollo astronauts traveled to the moon, they covered this distance in about 3 days. In our model, they traveled 100 feet in 3 days. That might not sound impressive until you remember they were in a spacecraft with no air resistance, traveling through vacuum at speeds of about 25,000 miles per hour in reality. In our model, that translates to about 2 millimeters per second, roughly the speed of a snail. Asterisk, space travel is slow, even at tremendous speeds, because the distances are so vast. Asterisk hash hash the sun. Over a mile away. Asterisk, now let's add the sun to our model. Asterisk, the sun sits approximately 150 million kilometers from Earth. That's about 93 million miles. We call this distance 1 astronomical unit, or O. It's the fundamental unit we use to measure distances in the solar system, asterisk, using our scale ratio. The sun in our model would be about 11.8 kilometers away. That's roughly 7.3 miles. Asterisk, let me help you visualize this. If Earth is a grain of sand in your hand, the sun would be about the size of a large grapefruit, roughly 109 millimeters or 4.3 inches across. Say more than 7 miles away. Asterisk, stand in the center of a city. The sun would be in the suburbs, about 7 or 8 miles out. If you were in Manhattan, it would be somewhere in Brooklyn or Queens. If you were in central London, it would be past Heathrow Airport. Asterisk, that's the scale we're dealing with. A grain of sand here, a grapefruit 7 miles away, and between them, nothing. Just empty space. No atmosphere, no gas clouds, nothing but vacuum. Asterisk, this is why space is called space. It's mostly emptiness. Even in our solar system, even between the sun and its closest planet, the distances are enormous compared to the sizes of the objects. Asterisk, light from the sun takes about 8 minutes and 20 seconds to reach Earth. In our model, light would travel from the grapefruit 7 miles away to the grain of sand in your hand in 8 minutes and 20 seconds. Light moves at about 1.4 miles per minute in our scaled down universe, fast, but not instantaneous. You could watch a beam of light leave the sun and count to 500 before it arrived at Earth. Asterisk, the sun itself is enormous compared to Earth. Its diameter is about 391,000 kilometers, roughly 109 times Earth's diameter. In our model, the sun is 109 times larger than our grain of sand. That works out to about 109 millimeters, or roughly 4.3 inches. A large grapefruit or small melon. Asterisk, the sun contains about 86% of all the mass in the solar system. Everything else, all the planets, all the moons, all the asteroids and comets combined, makes up less than 0.15%. In our model, the sun is by far the dominant object. The grapefruit outweighs everything else in the neighborhood by a factor of about 700 to 1. The inner planets within walking distance. Asterisk, let's add the other inner planets to our model. Asterisk, Mercury, the closest planet to the sun, orbits at about 58 million kilometers, roughly 36 million miles. In our model, Mercury would be about 4.6 kilometers from the sun. That's roughly to 0.8 miles. Asterisk, Mercury itself is small, only about 4,879 kilometers in diameter. In our model, it would be about 0.38 millimeters across, smaller than our Earth grain of sand. You need good eyes to see it. Asterisk, so in our model, Mercury is a tiny speck about 3 miles from the grapefruit sun, orbiting in the space between the sun and Earth. Asterisk, Venus orbits at about 180 million kilometers, roughly 67 million miles. In our model, Venus would be about 8.5 kilometers from the sun. That's roughly 5.3 miles. Asterisk, Venus is nearly Earth-sized, about 12,100 kilometers in diameter. In our model, Venus would be about 0.95 millimeters across, essentially the same size as our Earth grain of sand, maybe just slightly smaller. Asterisk, Mars orbits at about 228 million kilometers, roughly 140 million miles. In our model, Mars would be about 18 kilometers from the sun. That's roughly 11 miles. Asterisk, Mars is smaller than Earth, about 6,779 kilometers in diameter. In our model, Mars would be about 0.53 millimeters across, about half the size of our Earth grain of sand. Asterisk, so let me paint the full picture of the inner solar system in our model. Asterisk, the sun is a grapefruit, about 4 inches across. Mercury is a tiny speck about 3 miles away. Venus is a grain of sand about 5 miles away. Earth is a grain of sand about 7 miles away. Mars is a slightly smaller grain about 11 miles away. Asterisk, you could walk this entire distance. Start at the sun, walk 3 miles to Mercury, 2 more miles to Venus, another 2 miles to Earth, and 4 more miles to Mars. Total walking distance, about 11 miles. That's roughly a 3-hour walk at normal pace. Asterisk, the entire inner solar system, in our model, fits within an 11-mile radius. You could walk from the sun to Mars in an afternoon. Asterisk, but notice something, even in this compact region, the planets are tiny compared to the distances between them. For grains of sand scattered across 11 miles, the solar system, even the inner part, is mostly empty space. Asterisk hash has the asteroid belt. A sparse region asterisk between Mars and Jupiter lies the asteroid belt, a region containing thousands of rocky objects. In popular imagination, it's often depicted as a dense field of rocks where spacecraft must weave and dodge. Reality is very different. Asterisk the asteroid belt extends from about 300 million kilometers to about 500 million kilometers from the Sun, roughly 186 to 310 million miles. In our model, that's about 24 to 39 kilometers from the Sun, roughly 15 to 24 miles. Asterisk the largest object in the asteroid belt is Ceres, with a diameter of about 939 kilometers. In our model, Ceres would be about 0.07 millimeters across, smaller than a fine grain of sand. Most asteroids are far smaller. The vast majority would be invisible in our model, smaller than dust motes. Asterisk, and these tiny objects are spread across a huge volume of space. In our model, the asteroid belt is a region about 15 miles across, from 15 to 30 miles from the Sun, containing hundreds of thousands of objects, most smaller than dust specks. Asterisk the density is incredibly low. If you were standing in the asteroid belt in our model, you probably wouldn't see any asteroids at all. You'd have to search to find one, and when you did find one, the next nearest would be miles away. Asterisk space probes have flown through the asteroid belt multiple times. Not one has ever been in danger of collision. The belt is so sparse that you could fly a random path through it, and your chances of hitting anything would be essentially zero. Asterisk the asteroid belt is empty. Far emptier than you imagine. Asterisk hash Jupiter, half a football field away. Asterisk now we reach the giant planets, and the distances start to become seriously large. Asterisk Jupiter orbits at about 778 million kilometers from the Sun, roughly 484 million miles. In our model, Jupiter would be about 61 kilometers from the Sun. That's roughly 38 miles. Asterisk if the Sun is a grapefruit in the center of your city, Jupiter is nearly 40 miles away, out in distant suburbs or perhaps a neighboring town entirely. Asterisk Jupiter itself is enormous, about 139,820 kilometers in diameter. In our model, Jupiter would be about 11 millimeters across. That's roughly the size of a marble. Not a tiny marble, a standard glass marble, about 11 millimeters in diameter. Asterisk so Jupiter, in our model, is a marble sitting 38 miles from the grapefruit Sun. Asterisk this is a useful visualization. The Sun is a grapefruit. Jupiter is a marble. The distance between them is 38 miles. Earth is a grain of sand somewhere in between, about 7 miles from the grapefruit. Asterisk Jupiter has at least 95 known moons. The four largest Io, Europa, Ganymede, and Callisto, collectively called the Galilean moons because Galileo discovered them in 1610, would be visible in our model, though small. Asterisk Ganymede, the largest moon in the solar system, has a diameter of about 5,268 kilometers. In our model, it would be about 0.41 millimeters across, smaller than our Earth grain of sand. Ganymede would orbit Jupiter at a distance of about 84 centimeters, roughly 33 inches in our model. So the Jupiter marble would have a tiny grain orbiting it at about arm's length. Asterisk the other Galilean moons would be similar. Small grains orbiting the marble at distances of a few inches to a few feet. Asterisk Jupiter, like all the outer planets, is made mostly of hydrogen and helium. It has no solid surface. If you tried to land on Jupiter, you just sink deeper and deeper into increasingly dense gas until the pressure crushed you. Jupiter is essentially a failed star. If it had been about 80 times more massive, nuclear fusion would have ignited in its core. It would have become a star instead of a planet. Asterisk hash Saturn, 75 miles out. Asterisk Saturn orbits at about 1.4 billion kilometers from the Sun, roughly 890 million miles. In our model, Saturn would be about 110 kilometers from the Sun. That's roughly 68 miles. Asterisk if the Sun is in the center of your city, Saturn is in another city entirely, 70 miles away. Asterisk Saturn is nearly as large as Jupiter, about 116,460 kilometers in diameter. In our model, Saturn would be about 9.2 millimeters across, a slightly smaller marble than Jupiter, but still substantial. Asterisk Saturn's most famous feature is its ring system. The rings extend from about 7,000 kilometers to about 80,000 kilometers from Saturn's center, roughly 4,350 to 50,000 miles. In our model, The rings would extend from about 0.55 millimeters to about 6.3 millimeters from the center of the Saturn marble asterisk. Imagine a marble about 9 millimeters across with an extremely thin disk, extending about 6 millimeters beyond it in all directions. That's Saturn in our model. The rings are so thin relative to their width that if you scaled them up to the size of a football field, they'd be thinner than a sheet of paper. Asterisk Saturn has at least 146 known moons. The largest, Titan, is bigger than Mercury. Titan has a diameter of about 5,150 kilometers. In our model, Titan would be about 0.41 millimeters across, similar in size to Ganymede. Titan would orbit Saturn at a distance of about 96 centimeters, roughly 38 inches in our model. Asterisk, so the Saturn marble, 70 miles from the Sun, would have rings extending about a quarter inch beyond it, and a tiny grain called Titan orbiting about 3 feet away. Asterisk hash the ice giants into the distant reaches. Asterisk Uranus and Neptune, the ice giants, orbit in the cold, dark outer reaches of the solar system. Asterisk Uranus orbits at about 2.9 billion kilometers from the Sun, roughly 1.8 billion miles. In our model, Uranus would be about 228 kilometers from the Sun. That's roughly 142 miles. Asterisk if the Sun is in the center of your city, Uranus is in a city 140 miles away. If you're in New York, Uranus is in Philadelphia. If you're in London, Uranus is in Birmingham. If you're in Los Angeles, Uranus is in San Diego. Asterisk Uranus has a diameter of about 50,724 kilometers. In our model, Uranus would be about 4 millimeters across, a small marble, or perhaps a peppercorn. Asterisk Neptune orbits at about 4.5 billion kilometers from the Sun, roughly 0.8 billion miles. In our model, Neptune would be about 350 kilometers from the Sun. That's roughly 220 miles. Asterisk if the Sun is in New York, Neptune is in Boston. If the Sun is in London, Neptune is in Paris. The distance is substantial, several hours of driving even on highways. Asterisk Neptune has a diameter of about 49,240 kilometers. In our model, Neptune would be about 3.9 millimeters across, essentially the same size as Uranus, another small marble or peppercorn. Asterisk so let me paint the full picture of the solar system in our model. Asterisk the Sun is a grapefruit in the center. Mercury is a speck 3 miles away. Venus is a grain 5 miles away. Earth is a grain 7 miles away. Mars is a smaller grain 11 miles away. Jupiter is a marble 38 miles away. Saturn is a slightly smaller marble with rings 68 miles away. Uranus is a peppercorn 142 miles away. Neptune is a peppercorn 220 miles away. Asterisk the entire solar system, from the Sun to Neptune, spans to 120 miles in our model. That's about a 3.5-hour drive on a highway. You could drive from the Sun to Neptune in an afternoon. Asterisk, but notice the progression. As we move outward, the distances between planets grow larger and larger. Mercury to Venus is 2 miles. Venus to Earth is 2 miles. Earth to Mars is 4 miles. Mars to Jupiter is 27 miles. Jupiter to Saturn is 30 miles. Saturn to Uranus is 74 miles. Uranus to Neptune is 78 miles. Asterisk the outer solar system is far more spread out than the inner solar system. The spaces between objects grow larger as you move away from the Sun. Pluto and the Kuiper Belt, out where planets become rare. Asterisk Pluto, the famous dwarf planet, orbits in a region beyond Neptune called the Kuiper Belt. This is a vast ring of icy objects, remnants from the solar system's formation 4.6 billion years ago. Asterisk Pluto orbits at an average distance of about 5.9 billion kilometers from the Sun, roughly 3.7 billion miles. In our model, Pluto would be about 465 kilometers from the Sun. That's roughly 289 miles. Asterisk if the Sun is in New York, Pluto is in Pittsburgh. If the Sun is in London, Pluto is in Edinburgh. A 5-hour drive, easily doable in a day, but definitely a road trip. Asterisk Pluto has a diameter of about 2,377 kilometers. In our model, Pluto would be about 0.19 millimeters across, smaller than a grain of sand, more like a speck of dust. You need excellent vision or a magnifying glass to see it. Asterisk the Kuiper Belt extends from about Neptune's orbit to roughly 50 astronomical units, about 7.5 billion kilometers, or 4.6 billion miles. In our model, that's about 590 kilometers or 370 miles from the sun. Asterisk, this region contains hundreds of thousands of icy objects, most smaller than Pluto. In our model, it's a vast region from 220 miles to 370 miles from the sun, a span of 150 miles containing countless specks and dust motes scattered through space. Asterisk, the density is incredibly low, even lower than the asteroid belt. If you were standing in the Kuiper belt in our model, you could look in any direction and see nothing. Absolute emptiness. You'd have to search for hours or days to find even one of these tiny icy objects. And when you found one, the next would be miles away. Asterisk, the Kuiper belt shows us something important. The solar system doesn't have a clear edge. It doesn't suddenly end. It just gradually becomes emptier and emptier as you move outward, until eventually the sun's gravity is so weak that objects are barely held in orbit at all. Asterisk ## the Oort cloud. The true boundary asterisk beyond the Kuiper belt lies something even more vast and tenuous, the Oort cloud. Asterisk, the Oort cloud is a theoretical spherical shell of icy objects surrounding the entire solar system. We've never directly observed that the objects are too small and too far away, but we know it must exist because of comets, asterisk long-period comets. The ones that take hundreds or thousands of years to orbit the sun come from the Oort cloud. Occasionally, something disturbs an Oort cloud object, perhaps the gravity of a passing star, and it falls inward toward the sun, becoming a comet. Asterisk, the Oort cloud is thought to begin at about 2000 from the sun and extend outward to perhaps 100,000 astronomical units. That's about 300 billion kilometers to 15 trillion kilometers, roughly 186 billion to 9.3 trillion miles. Asterisk, in our model, the inner edge of the Oort cloud would be about 23,600 kilometers from the sun. That's roughly 14,700 miles. The outer edge would be about 1,180,000 kilometers from the sun. That's roughly 733,000 miles. Asterisk, let me put that in perspective. If the sun is a grapefruit in New York City, the inner edge of the Oort cloud is roughly in Hawaii, about 5,000 miles away across an ocean. The outer edge is about 3 times the distance from Earth to the moon in reality. Asterisk, actually, let me recalculate that more carefully to make sure I have the scale right. Asterisk, Earth is 12,740 kilometers in diameter. We've scaled it to 1 millimeter. That's a scale factor of 1.27 for times kiki to 1. Asterisk, the Oort cloud's inner edge is at about 2,000 astronomical units. 10 is about 150 million kilometers. So 2,000 astronomical units is about 300 billion km, or 3 times kiki meters, or 3 times 1,017 millimeters. Asterisk, divided by our scale factor. 3 times kc, 1.27 for times 1,010 equals about 0.36 times 107 millimeters equals 23,600 meters equals 23.6 kilometers. Asterisk, wait, that's not right. Let me recalculate. Asterisk, 10 is 149,597,871 kilometers. Let's round to 150 million kilometers, or 1.5 times kiki meters. 2,000. AU equals 3 times 1014. Meters equals 1,017 millimeters. Asterisk, our scale factor is 12,740 to 1,000 millimeters Earth's diameter to 1 millimeter. So we divide all distances by 12,740 to 1,003 times 1,017 millimeters. 12,740 to 1,000 equals to 0.35 times 1,010 millimeters equals 23,500,000 meters equals 23,500. km equals about 14,600 miles. Asterisk, yes, that's right. The inner Oort cloud is about 14,600 miles from the sun in our model. Asterisk, the outer edge at 100,000 astronomical units would be about 730,000 miles from the sun in our model. Asterisk, so if the sun is a grapefruit in New York, the inner Oort cloud begins roughly where Australia is on the other side of the planet, and the outer Oort cloud extends about 3 times farther than the moon's actual orbit around Earth. Asterisk, this is the true extent of the solar system, not the planets, which all fit within 200 miles in our model, but the Oort cloud, a vast spherical shell extending thousands of miles in all directions. Asterisk, and in all that space, A few trillion icy objects, most smaller than dust specks in our model, scattered so sparsely that you'd never see one even if you searched for years. Asterisk, the solar system is vast, and it's almost entirely empty. Asterisk hash Voyager, barely out the door. Asterisk Voyager 1, humanity's most distant spacecraft, launched in 1977. It's been traveling for over 47 years, moving at about 61,000 kilometers per hour, roughly 38,000 miles per hour. Asterisk, as of 2025. Voyager 1 is about 24 billion kilometers from Earth, roughly 15 billion miles. That's about 160. Asterisk, in our model, Voyager 1 would be about 1,900 kilometers from the Sun. That's roughly 1,180 miles. Asterisk, if the Sun is a grapefruit in New York, Voyager 1, after 47 years of continuous travel, has made it to approximately Kansas City. It's crossed about half the country. Asterisk, in our model, where Neptune is 220 miles from the Sun, Voyager has traveled about 1,180 miles, roughly 5 times Neptune's distance. Asterisk, that sounds like a lot, and it is. Voyager 1 is farther from the Sun than any human-made object has ever been. It's passed beyond the heliosphere and entered interstellar space. Asterisk, but remember the Oort cloud. The inner edge is about 14,600 miles from the Sun in our model. Voyager has covered about 1,180 miles. That's only about 8% of the distance to the inner Oort cloud. Asterisk, at its current speed, Voyager will reach the inner Oort cloud in our model in about 300 more years. It will exit the outer Oort cloud, finally leaving the solar system's gravitational boundary in about 30,000 years. Asterisk, so after nearly 50 years of travel, Voyager has barely begun its journey out of the solar system. It's in interstellar space, yes, space between the stars, but it's still gravitationally bound to the Sun, still technically part of the solar system, still in the Sun's neighborhood. Asterisk, the distances involved are so vast that even our fastest spacecraft, traveling for human lifetimes, barely make a dent. Asterisk hash the nearest star across an ocean. Asterisk, now we leave the solar system entirely and venture into true interstellar space. Asterisk, the nearest star to the Sun is Proxima Centauri, part of the Alpha Centauri system. It's about 4.4 light years away. Asterisk, a light year is the distance light travels in 1 year. Light moves at about 300,000 kilometers per second. In 1 year, that's about 9.46 trillion kilometers, roughly 5.88 trillion miles. Asterisk, Proxima Centauri is 4.4 light years away. That's about 40.1 trillion kilometers, or 24.9 trillion miles. Asterisk, in our model, Proxima Centauri would be about 3,150,000 kilometers from the Sun. That's roughly 1,957,000 miles. Asterisk, let me put that in perspective. The distance from Earth to the Moon is about 384,000 kilometers, or 239,000 miles. Proxima Centauri, in our model, is about 8.2 times the distance from Earth to the Moon in reality. Asterisk, if the Sun is a grapefruit in New York, Proxima Centauri is, well, it's not on Earth anymore. It's about 8 times farther than the Moon. Asterisk, actually, let me think about this differently. If the Sun is in New York, and we're using our scale, where's Proxima Centauri in terms of Earth geography? Asterisk, in our model, the Sun is a grapefruit in New York. The Oort cloud extends to about 730,000 miles away, roughly 3 times the distance to the Moon. Proxima Centauri is about 1,957,000 miles away, about 8 times the distance to the Moon. Asterisk, there's no good Earth-based analogy because Proxima Centauri is literally in space, beyond Earth's orbit, even in our scaled model. Asterisk, let me try a different approach. In our model, the Sun is a grapefruit. Earth is a grain of sand 7 miles away. Neptune is a peppercorn 120 miles away. Proxima Centauri is another grapefruit about 1,957,000 miles away. Asterisk, the space between the Sun and Proxima Centauri is so vast that even in our model, where Earth is a grain of sand, the stars are nearly 2 million miles apart. Asterisk, if you could walk in space in our model, and you walked at 3 miles per hour, walking from the Sun to Proxima Centauri would take you about 75 years of continuous walking. You need to walk every day, all day, for your entire life, just to reach the nearest star. Asterisk, in reality, Proxima Centauri is a small red dwarf star. It's much smaller and dimmer than the Sun. Its diameter is about 200,000 kilometers, roughly 14% of the Sun's diameter. In our model, Proxima Centauri would be about 15.7 millimeters across. Slightly larger than our Sun grapefruit. Actually, because wait, that can't be right. Asterisk, let me recalculate. The Sun's diameter is about 1,391,000 kilometers. Proxima Centauri's diameter is about 200,000 kilometers. That's about 14% of the Sun's diameter. Asterisk, in our model. The Sun is 1,391,000 kilometers. 12,740 to 1,000 equals 0.109 meters equals 109 millimeters. So about 4.3 inches, which I earlier compared to a grapefruit. Asterisk. Proxima Centauri would be 200,000 kilometers. 12,740 to 1,000 equals 0.0157. Meters equals 15.7 millimeters. That's smaller than the Sun, about 0.6 inches. More like a marble or large grape. Asterisk, so in our model, the Sun is a grapefruit. Proxima Centauri is a large grape about 2 million miles away. Asterisk, the space between them is empty. No planets, no asteroids, no gas clouds, nothing, just vacuum. The density of matter in interstellar space is about 1 atom per cubic centimeter, far emptier than any vacuum we can create in laboratories on Earth. Asterisk, in our model, the Sun and Proxima Centauri are two fruits, separated by a distance equivalent to 8 times the Earth-Moon distance. And in between, nothing. This is what interstellar space is like. Vast, empty, cold, dark. Stars are tiny specks separated by unimaginable distances. Asterisk # our galaxy. Stars like grains of sand on beaches. Asterisk our galaxy. The Milky Way contains somewhere between 100 billion and 400 billion stars. Let's use 100 billion as a reasonable estimate. Asterisk, the Milky Way is roughly 100,000 light years across. That's about 946 trillion kilometers or 588 trillion miles. Asterisk, in our model, the Milky Way would be about 74.3 billion kilometers across. That's roughly 46.2 billion miles. Asterisk, let me put that in perspective. The distance from Earth to the Sun in reality is about 150 million kilometers or 93 million miles. The Milky Way, in our model, is about 495 times the Earth-Sun distance in reality. Asterisk. If you could somehow shrink the Milky Way to the scale of the Earth-Sun distance, 150 million kilometers, then each star in the Milky Way would be, on average, separated from its neighbors by about 2,700 kilometers, roughly 1,680 miles. Asterisk, but we're using a different scale. In our model, where Earth is a grain of sand, the Milky Way is 46.2 billion miles across. Asterisk, the Sun is a grapefruit. There are 200 billion other grapefruits and grapes, and marbles scattered throughout a volume 46.2 billion miles wide. Asterisk, actually, the Milky Way isn't one-dimensional. It's a disk about 100,000 light years across and about 1,000 light years thick. So it's more like a pancake than a sphere. Asterisk, in our model, the Milky Way would be about 46.2 billion miles across and about 460 million miles thick. That's a very flat pancake, about 100 times wider than it is thick. Asterisk, and in this pancake, there are 200 billion stars, grapefruits, grapes, marbles scattered throughout. Asterisk, on average, each star would have about 231 cubic billion miles of space to itself. That works out to an average separation between stars of about 6,100 miles in our model. Asterisk, so in our model, stars are like cities. The Sun is New York. Proxima Centauri is about 2 million miles away, about 8 Earth-Moon distances. The next nearest star is a few million miles away in another direction, and so on, with stars scattered every few thousand to few million miles throughout the galaxy. Asterisk, the galaxy is crowded with stars compared to the space between the Sun and Proxima Centauri, but it's still mostly empty space. Even in our model, even shrunk down, stars are separated by distances larger than planets' orbits. Asterisk # Andromeda, another island visible in the distance. Asterisk, the Andromeda Galaxy, our nearest large galactic neighbor, is about 2.5 million light years away. That's about 23.7 trillion kilometers or 14.7 trillion miles. Asterisk, in our model, Andromeda would be about 1.86 trillion kilometers away. That's roughly 1.16 trillion miles. Asterisk, the distance from Earth to the Sun in reality is 150 million kilometers. Andromeda, in our model, is about 12.4 million times farther than the Earth-Sun distance in reality. Asterisk, there's really no good way to visualize this. The numbers are too large. Even in our scaled model, Andromeda is trillions of miles away. Asterisk, let me try this. The Milky Way, in our model, is about 46 billion miles across. Andromeda is about 1.16 trillion miles away. So Andromeda is about 25 times farther than the Milky Way's width. Asterisk, if you were standing at the center of the Milky Way pancake in our model and looked toward one edge, you'd see stars extending about 23 billion miles out. If you look toward the other edge, you'd see stars extending 23 billion miles in that direction. Total width, 46 billion miles. Asterisk, now look toward Andromeda. It's another pancake, similar in size to the Milky Way, but about 1.16 trillion miles away, about 25 Milky Way widths distant. Asterisk, in between the Milky Way and Andromeda is mostly empty space. A few dwarf galaxies, small collections of a few billion stars, but mostly just vacuum. The average density of matter drops to perhaps 1 atom per few cubic meters, even emptier than interstellar space within galaxies. Asterisk. Andromeda itself is larger than the Milky Way. It contains about 1 trillion stars, roughly 5 times what our galaxy has. It's about 220,000 light years across. Asterisk, in our model, Andromeda would be about 101 billion miles across, more than twice the Milky Way's width. So when you look toward Andromeda from the Milky Way in our model, you'd see a massive pancake of stars about twice as wide as our own galaxy, sitting about 1.16 trillion miles away. Asterisk, at this scale, galaxies become like islands in an enormous ocean. The Milky Way is one island. Andromeda is another, larger island visible in the distance. And between them, an ocean of emptiness, almost completely devoid of matter. Asterisk, the local group, the collection of about 80 galaxies that includes the Milky Way and Andromeda, spans about 10 million light years in our model. That would be about 785 billion miles. Within this volume, about 80 islands, galaxies of various sizes, float in the void. Asterisk, most are dwarf galaxies, small collections of a few billion stars, maybe 10,000 or 20,000 light years across. In our model, these dwarf galaxies would be pancakes about 5 to 10 billion miles across, scattered throughout the 785 billion mile wide volume of the local group. Asterisk, hash, the observable universe, so large it breaks the model. Asterisk, the observable universe is about 93 billion light years in diameter. That's about 880 trillion kilometers, or 547 trillion miles. Asterisk, in our model, the observable universe would be about 69 trillion millimeters across. Let me convert that to something more manageable. That's about 69 billion meters, or 69 billion kilometers, or about 43 billion miles. Asterisk, these numbers are so large that the model starts to break down. Let me try to give you perspective a different way. Asterisk, the distance from Earth to the Sun in reality is about 150 million kilometers. The observable universe in our model would be about 4.6 times kc times that distance. That's 460 quadrillion times the Earth-Sun distance. Asterisk, or think about it this way. In our model, Earth is a grain of sand. The Milky Way is a pancake about 46 billion miles across. The observable universe contains about 2 trillion galaxies, each one a pancake ranging from a few billion to over 100 billion miles across, all scattered throughout a volume about 43 billion miles wide. Asterisk, at this scale, even galaxies become like grains of sand. If you could somehow compress each galaxy with its billions of stars down to a single point, those 2 trillion points scattered throughout the observable universe would be separated by an average distance of about 21 billion miles in our model. Asterisk, so galaxies in the universe are like stars in a galaxy, tiny points of light separated by vast distances, with most of the volume being empty space. Asterisk, and remember, the observable universe is just what we can see. The actual universe might be much larger. It might be infinite. What this model teaches us. Asterisk, so what have we learned by shrinking Earth to a grain of sand? Asterisk, first, we've learned that space is almost incomprehensibly empty, even in our scaled model where Earth is small enough to hold between your fingers. The distances are enormous. Asterisk the moon is 100 feet away. 3 bus lengths. That seems close until you remember it's the closest celestial object to Earth. And there's nothing but vacuum in between. Asterisk the sun is 7 miles away. A grapefruit in the suburbs. And between Earth and the sun, nothing, just empty space. No air, no gas, no particles, nothing. Asterisk the solar system extends for hundreds of miles. All the planets, all the moons, all the asteroids, everything orbits within a 200-mile radius of the sun. Beyond that, the Kuiper belt extends to about 370 miles. The Oort cloud extends to about 730,000 miles, about 3 times the actual Earth-Moon distance. Asterisk. And in all that volume, in all those hundreds of thousands of miles, there are 8 planets, a few dozen large moons, a few dwarf planets, hundreds of thousands of asteroids and Kuiper belt objects, and trillions of Oort cloud comets, almost all of them smaller than a grain of sand in our model, scattered so sparsely that you could wander for years and never see anything. Asterisk the nearest star is about 2 million miles away in our model, about 8 times the actual distance from Earth to the moon. Between the sun and Proxima Centauri, nothing, absolute emptiness. No planets, no asteroids, no gas, no dust, just vacuum with an average density of 1 atom per cubic centimeter. Asterisk the Milky Way contains 100 billion stars scattered across 46 billion miles. On average, stars are separated by thousands or millions of miles. The galaxy is crowded with stars compared to intergalactic space, but it's still mostly empty. Asterisk, and the universe contains a trillion galaxies scattered across distances so vast that even our model breaks down trying to represent them. Asterisk second, we've learned that we're insignificant, not in a depressing way, in a perspective-giving way. Asterisk Earth is a grain of sand, the entire planet, all the continents, all the oceans, all the mountains and valleys, all the cities and forests compressed to 1 millimeter, something you could barely feel between your fingers. Asterisk every human who has ever lived, all 100 billion of us throughout history, lived on that grain of sand. Every war, every empire, every discovery, every work of art, every moment of joy and sorrow, all of it happened on a speck so small you could lose it on a beach. Asterisk the solar system extends for hundreds of miles, but Earth is just 1 grain of sand in that vast volume. The sun is a grapefruit. Jupiter is a marble. Everything else is smaller grains, specks, dust motes. Asterisk the Milky Way extends for billions of miles, containing 100 billion stars. The sun is just 1. Earth orbits 1 ordinary star among the 100 billion. Asterisk the universe contains 1 trillion galaxies. The Milky Way is 1 among the trillion. Earth is 1 planet among the 100 billion trillion planets in the observable universe. Asterisk we're tiny, almost impossibly tiny. A grain of sand orbiting 1 grapefruit in a galaxy of 200 billion grapefruits. In a universe of 2 trillion galaxies. Asterisk, and yet Dan, this is the beautiful part, we're here. We exist. We can think, wonder, understand. On this grain of sand, matter has organized itself into forms that can contemplate the cosmos. We can build telescopes, make observations, develop theories, and gradually piece together the nature of reality. Asterisk where the universe's way of knowing itself. Through us, matter has become aware. That's remarkable. Asterisk third, we've learned that the universe operates on scales far beyond human intuition. We evolved to understand distances we could walk in a day, objects we could see and touch. We're good at understanding human scale things, rooms, buildings, cities. Asterisk, but space operates on scales billions of times larger. Even in our model, where we've shrunk everything by a factor of 12.7 billion, the distances are still enormous. The nearest star is still millions of miles away. The galaxy is still billions of miles across. Asterisk our brains simply didn't evolve to handle scales this large. We can do the math. We can write down the numbers. We can build models like this one. But we can't truly feel the distances. We can't truly comprehend them in the visceral, intuitive way we comprehend the distance across a room. Asterisk that's okay. That's normal. Nobody can truly comprehend cosmic scales. The best we can do is use models, analogies, comparisons, tools that help us think about the unthinkable. Asterisk this grain of sand model is 1 such tool. It doesn't make the universe comprehensible, nothing could do that, but it makes the universe thinkable. It gives you a framework, a way to organize these vast distances in your mind. Asterisk hash. Other objects in our model. Asterisk let's add a few more interesting objects to our model. To give you additional reference points, asterisk the International Space Station orbits Earth at an altitude of about 400 kilometers, roughly 250 miles. In our model, that's about 31 millimeters above Earth's surface, about 1.5 inches, asterisk. So if Earth is a grain of sand sitting on a table, the ISS is orbiting about 1.5 inches above the table, closer to Earth than the thickness of a smartphone. Asterisk the astronauts on the ISS aren't far from Earth at all. They're right there, practically touching the surface in our model. They're still well within Earth's atmosphere in terms of gravitational influence. They feel about 90% of Earth's surface gravity. They're weightless only because they're in continuous free fall, orbiting so fast that they keep missing Earth as they fall. Asterisk geostationary satellites, like those used for TV and communications, orbit at about 35,786 kilometers, roughly 22,000 to 136 miles. In our model, that's about 2.8 meters above Earth's surface, about 9 feet. Asterisk so communication satellites orbit about 9 feet above the Earth grain of sand, still very close, well within what you'd consider near Earth in the model. Asterisk the James Webb Space Telescope orbits the Sun at a location called the L to Lagrange point, about 1.5 million kilometers from Earth, roughly 930,000 miles. In our model, that's about 118 meters from Earth, about 387 feet, or roughly the length of a football field plus the end zones. Asterisk so the James Webb Telescope, humanity's most advanced space telescope, sits about a football field away from the Earth grain of sand in our model, orbiting the grapefruit sun along with Earth. Asterisk Mars at its closest approach to Earth comes within about 55 million kilometers, roughly 30 per million miles. In our model, that's about 4.3 kilometers, about 2.7 miles. Asterisk when Mars and Earth are on the same side of their orbits. They're separated by about 3 miles in our model. Two grains of sand, one slightly smaller than the other, about 3 miles apart. That's when we send spacecraft to Mars during these close approaches. That happened roughly every 26 months. Asterisk the Voyager Golden Record is a phonograph record carried by both Voyager spacecraft. It contains sounds and images from Earth, intended to communicate something about our world to any extraterrestrial intelligence that might find it. Asterisk the Voyager Golden Record is about 30 centimeters in diameter, roughly 12 inches. In our model, it's about 0.004 millimeters across, about 20 for nanometers. That's about the size of a large virus. Asterisk so Voyager 1, currently about 1,180 miles from the Sun in our model, carries a virus-sized record containing information about a grain of sand called Earth. Asterisk if an alien civilization found Voyager in our model, they'd be finding a virus-sized artifact from a civilization that lives on a grain of sand, orbiting the grapefruit 1,180 miles away. Asterisk the cosmic distance scale is humbling in every direction. Not only is space vast, but we're tiny. Time and distance. Asterisk there's another way to think about cosmic distances. In terms of time, asterisk light travels at about 300,000 kilometers per second, roughly 186,000 miles per second. That's the fastest speed possible in the universe. Nothing can go faster. Asterisk light from the Sun takes about 8 minutes and 20 seconds to reach Earth. So when you look at the Sun, you're seeing it as it was 8 minutes and 20 seconds ago. The Sun could have exploded 8 minutes ago, and you wouldn't know yet. You'd still see it shining normally, completely unaware that it was already gone. Asterisk light from Jupiter, when it's closest to Earth, takes about 33 minutes to arrive. When you look at Jupiter through a telescope, you're seeing it as it was half an hour ago. Asterisk light from Pluto takes about 5.5 hours. You're seeing Pluto as it was earlier today. Asterisk light from Proxima Centauri takes 4.4 years. When you look at Proxima Centauri, you're seeing light that left that star over 4 years ago. You're seeing the past. If Proxima Centauri exploded tomorrow, we wouldn't know about it until 2029. Asterisk light from the center of our galaxy takes about 26,000 years. When you look toward the galactic center, you're seeing it as it was 26,000 years ago, when humans were still hunter-gatherers in the Stone Age. Asterisk light from Andromeda takes 2.5 million years. When you look at Andromeda, you're seeing it as it was 2.5 million years ago, when early human ancestors like Homo habilis were just beginning to use tools. Asterisk light from the most distant galaxies we can observe takes about 13.4 billion years to reach us. We're seeing those galaxies as they were just 400 million years after the Big Bang, when the universe was young and the first galaxies were forming. Asterisk, the universe has a history written in light. The farther you look, the further back in time you see. Every photon that enters your eyes tonight has been traveling through space for some amount of time. Perhaps 8 minutes from the sun, perhaps billions of years from a distant galaxy. Asterisk, astronomy is time travel. When you look at the night sky, you're not seeing things as they are now. You're seeing things as they were. The universe you observe is a patchwork of different time periods, all arriving at your eyes simultaneously. Asterisk, in our grain of sand model. This means something interesting. If Earth is a grain of sand and Proxima Centauri is a grape to million miles away, then any information you receive from Proxima Centauri is over 4 years old. You're always seeing the past. Asterisk, if you wanted to have a conversation with someone on a planet orbiting Proxima Centauri, you'd send a message. It would take 4 years to arrive at light speed. If they responded immediately, their response would take another 4 years to reach you. That's an 8.5-year round trip for a single exchange of hello and hello back. Asterisk, you could ask someone a question and they'd answer before your children were born. Conversations across interstellar distances are slow beyond comprehension. Asterisk ##. The Fermi paradox in our model, asterisk, the grain of sand model, also helps illustrate something called the Fermi paradox. Asterisk, the Fermi paradox asks, if the universe is so vast, if there are so many stars and planets, if life arose on Earth, then where is everyone else? Why haven't we seen any sign of alien civilizations? Asterisk, there are many possible answers, but one is simply distance. The universe is so vast, and the speed of light is so limiting, that civilizations might exist, but be unable to contact each other. Asterisk, in our model, Earth is a grain of sand orbiting a grapefruit called the Sun. If there's another civilization on another grain of sand orbiting another grapefruit, the nearest they could be is about 2 million miles away, the distance to Proxima Centauri. Asterisk, any signal they send us would take 4 years to arrive. If they've been broadcasting for a century, as we have, their signals have reached every star within about 100 light years. In our model, that's a sphere about 78 million miles in radius around their home star. Asterisk, but there are maybe 60,000 stars within 100 light years of Earth. If only 1 in 1,000 has a civilization capable of broadcasting, that's 60 civilizations within detection range. And we're all shouting into the void, separated by millions of miles. Our signals growing weaker the farther they travel. Asterisk, the signals would be faint, incredibly faint. You need enormous radio telescopes pointed in exactly the right direction, at exactly the right frequency to detect them. And even then, it might take decades of searching. Asterisk, the universe might be full of civilizations, hundreds, thousands, millions of them scattered throughout the galaxy. But they're all grains of sand orbiting grapefruits separated by millions of miles. They're all isolated, unable to reach each other, unable to communicate except through faint radio whispers that take years or decades or centuries to cross the void. Asterisk, the Fermi paradox might not be a paradox at all. It might just be distance. The universe is so large that even if we're not alone, we might as well be. Asterisk ## the pale blue dot. Asterisk, in 1990, the Voyager 1 spacecraft, then about 6 billion kilometers from Earth, roughly 3.7 billion miles, turned its camera around and took a photograph of the solar system. In that photograph, Earth appears as a tiny pale blue dot, less than a pixel in size, suspended in a sunbeam. Asterisk, the astronomer Carl Sagan reflected on this image in his book Asterisk, Pale Blue Dot. Asterisk. He wrote about how everyone you love, everyone you know, everyone you've ever heard of, every human being who ever lived out their lives on that mote of dust suspended in a sunbeam. Asterisk, in our grain of sand model, that photograph was taken from about 470 miles away, about the distance from New York to Pittsburgh, or London to Edinburgh. From that distance, Earth, the grain of sand, was barely visible, a tiny speck reflecting sunlight. Asterisk, from the perspective of space, from even modest distances, Earth vanishes. It's too small, too faint. It blends into the background. You have to know exactly where to look to find it. Asterisk, and yet, on that invisible speck, everything human has happened. Every civilization, every empire, every war, every moment of peace, every work of art, every scientific discovery, every technological achievement, every kindness, every cruelty, every moment of love and hate and joy and sorrow. Asterisk, all on a grain of sand. Asterisk Sagan wrote, "There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the pale blue dot, the only home we've ever known." Asterisk the grain of sand model brings this home. It makes it visceral. You can hold a grain of sand between your fingers. You can feel how small it is. You can imagine dropping it and losing it. You can picture it sitting in a vast room, or scattered on a beach, or lost in an ocean. Asterisk that's Earth. That's home. That's us. # what does it mean? Asterisk so what does all this mean? Why does it matter that if Earth were a grain of sand, the sun would be a grapefruit 7 miles away, and the nearest star would be a grape 2 million miles away? Asterisk it matters because it gives you perspective, scale, context. Asterisk you live on a planet that, in cosmic terms, is essentially invisible. A grain of sand orbiting an ordinary grapefruit in a galaxy of 200 billion grapefruits. In a universe of 2 trillion galaxies. Asterisk every concern you have, every problem you face, every moment of stress or anxiety, it all happens on that grain of sand. That doesn't make your problems unimportant. Your life matters to you, and it should. But it can help to remember the context, the borders we fight over, the resources we compete for, the differences we emphasize. They're all on a grain of sand. Asterisk from the perspective of Proxima Centauri, 2 million miles away in our model, Earth is invisible. From Andromeda, 1 trillion miles away, the entire Milky Way galaxy is just a smudge of light. Our individual concerns, our nations, our entire civilization completely invisible. Asterisk that should be humbling, but it should also be liberating. Asterisk if we're so small, if the universe is so vast, if we're grains of sand in an ocean of emptiness, then maybe our divisions aren't as important as we think. Maybe the things that unite us, the fact that we're all on this grain of sand together, all breathing the same air, all looking up at the same stars, maybe those things matter more. Asterisk maybe we should take better care of our grain of sand. It's the only one we have. And while there might be countless other grains of sand scattered throughout the universe, we can't reach them. They're millions of miles away. We're stuck here, on this one, for the foreseeable future. Asterisk that makes Earth precious. Not because it's large, it's a grain of sand. Not because it's special cosmically, it's one planet among the 100 billion trillion. But because it's ours. Because it's home. Because it's the only place in the universe we know for certain that has life, consciousness. Wonder. Asterisk the grain of sand model also reminds us that we're capable of extraordinary things. We figured all this out. We measured these distances. We calculated the scales. We built telescopes and spacecraft. We sent probes to visit the outer planets and beyond. We're mapping the universe, grain of sand though we are. Asterisk we're tiny, yes, but we're also remarkable. We're matter that has become aware, consciousness that can contemplate its own insignificance. We're the universe's way of knowing itself. Asterisk ## the final picture. Asterisk let me paint one final picture of what the universe looks like. If Earth is a grain of sand, asterisk you're holding a grain of sand. It's about 1 millimeter across, barely visible. You can just feel it between your thumb and forefinger. Asterisk now imagine you're standing in a field. Place the grain of sand on the ground. That's Earth. Asterisk walk 100 feet, about 30 meters, and place another smaller grain. That's the moon. Asterisk get in a car and drive 7 miles. Place a grapefruit on the ground. That's the sun. Asterisk drive back toward the Earth grain, but stop about 3 miles from the grapefruit. Place a tiny speck there. That's Mercury. Drive to 5 miles from the grapefruit. Place another grain. That's Venus. Drive to 7 miles back to where Earth is. Drive to 11 miles and place a small grain. That's Mars. Asterisk drive 38 miles from the grapefruit. Place a marble there. That's Jupiter. Drive to 68 miles. Place a slightly smaller marble with thin discs around it. That's Saturn. Drive to 142 miles. Place a peppercorn. That's Uranus. Drive to 220 miles. Place another peppercorn. That's Neptune. Asterisk you now place the entire planetary solar system. 8 objects ranging from specks to marbles, scattered across 120 miles, all orbiting the grapefruit sun. Asterisk keep driving. Drive 4 hours. Drive 4 days. Eventually, after driving about 370 miles, you'll reach the outer edge of the Kuiper Belt. Scatter a few specks of dust in this region. Asterisk keep driving. Drive for weeks. Drive across the country. Drive across continents. Drive across oceans. After driving about 14,600 miles more than halfway around the actual Earth, you'll reach the inner edge of the Oort cloud, scatter a few trillion specks of dust in a sphere around the entire solar system, extending out to about 730,000 miles from the sun. Asterisk, now you need to leave Earth, get in a spacecraft, travel about 8 times the distance from Earth to the moon, about 2 million miles. Place a grape, that's Proxima Centauri, asterisk, keep traveling, scatter to 100 billion more fruits, grapefruits, grapes, marbles throughout a disk about 46 billion miles across and 460 to million miles thick. That's the Milky Way galaxy. Asterisk, travel about 1.16 trillion miles. Place another disk of fruits about 101 billion miles across. That's Andromeda. Asterisk, scatter about 80 more disks of various sizes throughout a region about 785 billion miles across. That's the local group. Asterisk, keep going. Scattered a trillion disks, galaxies throughout a volume so vast that numbers become meaningless. Trillions upon trillions of miles. Distances so large that even light takes billions of years to cross them. Asterisk, that's the universe. Asterisk, and somewhere in all that vastness, somewhere among those 2 trillion galaxies, somewhere among the 200 billion trillion stars, somewhere among the countless grains of sand orbiting those stars, there's one particular grain. Asterisk, it's the third grain out from a medium-sized grapefruit in an average suburb of a spiral disk of 200 billion fruits. On that grain, life evolved. Consciousness emerged. Beings capable of wonder appeared. Asterisk, those beings looked up at the night sky and asked, how big is all this? Where are we? What does it all mean? Asterisk, and gradually, over centuries, they figured it out. They measured the distances. They calculated the scales. They understood. Asterisk, they understood that they live on a grain of sand, that their sun is a grapefruit 7 miles away, that the nearest other grapefruit is 2 million miles away, that their galaxy contains 100 billion grapefruits, that the universe contains 2 trillion galaxies. Asterisk, they understood how small they are, how vast the universe is, how alone they might be. Asterisk, and yet, knowing all this, they persisted. They continued to wonder, continued to explore, continued to try to understand. Asterisk, because that's what consciousness does. That's what makes us remarkable. Not our size were grains of sand. Not our cosmic importance were essentially invisible. But our capacity to understand. Our ability to look up at the infinite and comprehend it, at least partially. Asterisk, if Earth were a grain of sand, the universe would be impossibly, incomprehensibly vast. Distances measured in millions and billions and trillions of miles. Voids so empty that even light takes years or centuries or millennia to cross them. Asterisk, but here we are, on our grain of sand, looking up, wondering, understanding. Asterisk, and that, more than size or scale or cosmic significance, is what makes us extraordinary. Asterisk, if you've made it this far, thank you for joining me on this journey through scale. If you found this exploration valuable, a like or subscribe would really help the channel continue making content like this. These deep explorations take enormous effort to create, and your support makes it possible. Asterisk, and remember, you're not just living on Earth. You're living on a grain of sand orbiting a grapefruit in a universe so vast that even after shrinking it down, the nearest star is still 2 million miles away. Asterisk, that's humbling. That's awe-inspiring. That's reality. Asterisk, sleep well tonight. And tomorrow, when you see a grain of sand on a beach or in your hand, remember, that's us. That's home. That's everything we've ever known. Asterisk, and it's beautiful. Asterisk, good night.